After starting data warehouse and data lake house, it's time to consider how do we put data into these storage places, right? Data warehouse, data lake house, either it's a relational database or it's a file system. Eventually, you need some means to move data into this in order for future analysis. And this traditionally is done by a process called ETL. ETL stands for extracting, transforming, and loading. So looking at the idea is if you want to move data into data warehouse, first you need to read it from the source, which is extracting the data from the source. This source can be any application or any customer users or an API, all these things. Then you will do some transformation. You want to filter out certain data. You want to do some derived calculation. Then you probably will join the data set to each other and doing some aggregation. After all this transformation, you will load the data, which means saving that into a data warehouse or data mart. And traditionally, this is called loading. So ETL, extracting, transforming, and loading, are the process that we use in order to populate the data warehouse and data lake. the if you consider the source, right, different source systems will generate data that either comes in different format and frequency. Some, for example, the date format. I think last time we looked at the U.S. government data of car price, gas price, and transportation CPI. Even those data from different U.S. government agency, but same U.S. government, right? But different agency, they have different formats for the month, year, month, date, right? Let alone if you think about different commercial providers, they are very likely to give you data in different formats. And if you have international providers, maybe the currency may be different, the date format may be different. Is that month, day, year, or date, month, year? That's always an ongoing the question when you try to consolidate data from US and UK. So the different data sources will provide you with the data with different format and frequency. Sometimes some data comes in, for example, transactional data, like selling event, comes every second, every minute. But then the car price, gas price index will come in a much slower pace, maybe coming every month. And if they have different formats, such as the year months format difference we talked about, they may not be joinable from different to other sources, right? Sometimes like medical history versus medical device purchase history, they may maybe come from different systems. Medical history comes from insurance claim process. Medical device purchase history come from an e-commerce website. They have different sources, and when these data were generated, they belongs to different company, so they have different keys. The same customer maybe have a ID of ABC in one company's system and have the ID of 123 in another company's system. How do you recognize this ABC is the same person, same real world person as this 123? So they may not be joinable from different sources, and sometimes they may not be clean. For example, like patient social networking content. How do you check a patient status if he or she keep on posting some information about chest pain? Is that something you need to worry about? But chest pain can caused by many things. Maybe just maybe just because he or she slept funny the other day, so and hurt his rib, or maybe it's caused by a certain procedure. Who knows? So these are the potential data source for you, but you need to cleanse them and remove unrelated and unimportant information. These are why you need ETL. Why do you need a certain kind of a transformation? Data from multiple sources should be cleansed, consolidated, merged, and stored together. And you will derive or aggregate certain values. And then, after all these are performed, you will consolidate them and eventually load them into more accessible schema. Like the example we have before, the medical device purchase history and the medical claim history. You want to combine them and check customer or patients' activity um, by consolidating the data from two different sources, right? And possibly cleans the social security, social network information. This customer after the practice, after the operation, feel chest pain for 3 days and fourth day getting better, something like that. The graphical example, you have two CSV files, each from one source. Use a linked service to connect to Azure, for example, and move that into two different CSV dataset. They are actually just relational dataset, but coming from CSV file. And we did some copy into relational database. So this part is extraction. And this copy and possibly some kind of a twist and turn data manipulation. This is a transform. And finally, we load into a SQL Server linked service, load that into a SQL Server table or two SQL Server tables. This is when we do the loading. So extraction from a linked service, some kind of transformation. Here we just show a copy, but definitely you can have more. Then loading into the final SQL Server. And talk about this loading, right? Real world activities happen like a stream of events over time. Like in the hospital, patients coming in, you cannot determine when the patient will come. And then in e-commerce website, orders coming in every second. So, but usually when loading table, the traditional way is wait until a day, a time and load every batch, right? We want to save the transaction data into one file or a couple of files. And when it's time, the transaction system is less busy, not so busy. We will do a loading, and this works before in traditional sense because a lot of enterprise applications they do have up and down scaling scale up and scale down events. Like in a traditional brick and mortar store, the sale begins at 10 o'clock, 10 a.m., ends at 10 p.m. After 10 p.m., there's no more transaction. At that time, the system is quiet and does not have any workload or very few workload. You can utilize this time, the system power that is available during this time, to run your loading and extraction and transformation, right? So basically, every day at night, the late night after the official business close, some IT guy will run the ETL job using the same hardware just to avoid wasting of it, right? So you will collect all the events happening that day and process them together. And overnight, you get the data ready, upload it to data warehouse, get it aggregated, joined, and generated some dashboards. The next morning, as they start operation, CEO comes in and reads through the dashboards just get generated. That's a perfect way of utilizing time and utilizing resource. However, as we go into cloud world and going global, going into the big company, big data time, you really don't know when you will have this kind of opportunity of empty slot of time for you to utilize. Say taking example like Amazon.com or Microsoft Office, around the globe every day there's someone running. There's someone utilizing their system, and the system has be keep on running. So events coming in like a stream, and the stream each stream consists of tiny little dots, like a river stream. tiny little water drops forming the stream as a flow, keep on coming and keep on going. This is not a new concept or practice. This happens even before a long time ago, and but it's getting more attention as we have more and more big data operations. We have a global operation. We have an online operation. The store is always open. Online store is always open, and your customer may be global, so they may come at any time. That's when we see the velocity of data and the variety of source and format. These are like a part of the big data challenges. For example, like we talk about e-commerce, and also there's IoT. Even if you are sleeping, your cell phone is still sending out a message, right? Your smartphone is still sending out a message. So all these data are keep on coming and form the stream. So streaming processing start to pick a momentum recently. Before that, um, before the big data challenge, like 10 years ago, the majority of the ETL processing was still batch that you run on time. But these times, as personal devices in the usage of personal device increase and as the challenge of big data comes in, more and more people are considering utilizing streaming ETL. One example is the Azure IoT example. You can see some of the IoT products and the streaming products available from Azure. Of course, you have the data sources, those all different resource devices. Like it's an industry sensor, right? Some kind of device, some kind of laptop, and you have the car and the watch, etc., etc. All these are generating small events every second or every minute, sending that to a service called Azure IoT Hub. This Azure IoT Hub service will map to your the device, have a digital mapping of the device, sending the message to different systems. It can be sent to Azure Event Grid. It can be sent to Azure Stream and Analytics. It can be sent to digital twin streaming services, and then from there, you can send this to different places for further processing. Data warehousing is just one of them. Data warehousing and data lake is just one of them. You can directly send to Power BI for visualization and querying. You can also send it to serverless functions for further processing, such as monitoring. I believe we talked about one of the municipals in southern state using IoT for water level measuring, for flood predicting, right? So those water level measurement will be sent to event grid every minute, and some functions will be utilized to calculate the potential of flooding and send out warnings on real time. That's the power of streaming. But for our system, really right now the difference between batching and the streaming are gradually get blurred. You will still see a lot of batch processing, but the tools that support batch processing now start to also support streaming. Most of the industry standard tools they start to support streaming. So there's really it's just more like a mindset change instead of a new skill. You can pretty much use the similar skill that you already have to switch from batch processing to streaming processing. With that, let's take a look at the traditional data processing flow. In the traditional data processing flow, we have the ETL. How do we move data as ETL? It starts with a source system, right? We do the extraction, but after extraction, we don't directly immediately do loading. Instead, before loading, we will put data first into staging area and move that through a series of transformations into data warehouse and into data mart. Transformation happened, so data will be loaded into staging first. Then transformation will happen based on these staging files. Here is where we do filtering, joining, aggregating all this data into core data warehouse. Then move from data warehouse to data mart. There might be multiple layers of staging, right? If you want to calculate some value in between, you can have raw data somewhere here and also have more staging layers serving as the intermediate result storage during this calculation. So data will move from source to staging to data warehouse to data mart. And staging area is only used for ETL. Once the ETL finishes, usually the best practice is to clean up staging area, deleting everything there, so that it's ready for the next run. ETL workflow will move data between different layers of staging areas tables to data warehouse and finally to data mart. And look backwards, you will design data warehouse and data mart first. What happened is data mart is usually for data mart there's less ambiguity. We know what it is, why we build that, and we know how it should look like. So there's much more certainty in designing a data mart. That's why we always design data mart first. Because data mart could definitely be in star schema, and data mart is business oriented, so it has to reflect a certain particular business flow or activity. This business flow or activity is so well defined that we can identify the fact and the dimension that it involves, and if we are not clear about it, that's when you start doing that Kimball Enterprise Bus exercise. Talk to the customer, talk to the business, and identify what activities are involved in this business flow. Then once you get that, you organize the data by that business flow by utilizing the enterprise bus. Then you go to the central storage, right? The data mart, this data comes from central storage or data warehouse or data lakehouse. I didn't put a data warehouse or lakehouse here, I just put a central storage because this can either be a data lakehouse or a data warehouse, or even just the simple data lake. As we discussed before, for this area, you have a lot of flexibility in designing. It can be star snowflake schema, the data warehouse, or it can be a third normal form compliant ODS. Since data mart have been designed as star schema, data warehouse can be third normal form or snowflake schema, or even a logical data warehouse, which is a layer of views on top of ODS. Then